Hello. Well, depending on which of my classes you're in, we are either beginning or continuing our section or our chapter on conics. The conic sections are, and if you've already heard this from me, you can skip if you like. But here's the options. You could have a circle, an ellipse, a hyperbola, or a parabola. Now, most of these you've probably heard of before, except for maybe the hyperbola. But here's where conic sections come from. If you take two cones and stack them by their tips, then conic sections are created by cutting or intersecting those cones in different ways. And there's those four ways that you can intersect the cones. The first one is a circle, so that's when it intersects parallel to the base of one of the cones. If it's not parallel to the base of one of the cones, but it only intersects one cone, then it's either an ellipse or a parabola. So an ellipse is when you're intersecting the cone, but you're not going outside of it. So you're going completely around the cone, and you get your ellipse, which is an oval. The parabola is when you're intersecting just one cone, but it's exiting through the base or the top of the one, so that you end up with just part, I guess you could say, of an ellipse, but the parabola continues on forever. A hyperbola is when the plane intersects both cones. When it intersects both cones, you end up with kind of like two parabolas, you could say. But both of them are the same. So the hyperbola, you'll have one U going up or sideways, and the other one going down or the other direction sideways. So in this section, we're going to look at ellipses. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. So you have 2 points, which we call foci, here and here. They're always inside the ellipse, and they're always along the major axis of the ellipse. So the longer axis of the ellipse, where it's pulled out more, okay, is the major axis. And these 2 points, if you take those distances and this distance and add them, that's what gives you the points that form the ellipse itself. If you'll remember back with the definition of a circle, that was when you just had a center. Oh, that's really bad. I better draw the circle first. There we go. And the definition of circle was all the points at the radius all the way around. Okay? So this is very similar, but you're looking at 2 points because it's pulled out. It's not perfectly circular. So we have the foci. We also have a center of the ellipse. So the center would be about right here. It's halfway between the foci and halfway between the vertices. These are two vertices. Those are our most important vertices for our ellipse. They're along the major axis. And then the other 2 vertices go in the other direction like this. And that's what helps you draw your ellipse. The ellipse can be horizontal, like this picture, or vertical, like this one. The major axis, as I said, always goes along the longer stretch of the ellipse. So in this case, the major axis is vertical. In that case, the major axis was horizontal. Then the minor axis goes along the shorter distance. Both those axes go through the center, and the major axis will also go through the foci. And then the vertices, again, you've got the major vertices along the major axis, and then the minor vertices along the minor axis. And here's just two more pictures of the same thing with them either horizontal or vertical. So how do we write the equation of an ellipse? If you'll remember back, the equation of a circle was x minus h squared plus, don't write this down because this is a circle, plus y minus k squared equals 1. So it had a center at HK, and then it was just a circle from there. An ellipse is different because it has a squared and b squared on the bottoms, depending on which direction it goes. And the a squared and the b squared are distances from the center to the vertices. So if your ellipse is centered at the origin, then you don't have to worry about h and k. You just have x squared and y squared. Now, what's the difference between, in this case, a squared is below the x, and here a squared is below the y? In terms of an ellipse, the a will always be the bigger number, the bigger distance, and it will always go along the major axis. So in this first picture, the major axis is horizontal, so that is why A is this distance here, and that is why it goes under x squared, because x squared is the horizontal axis. In the second picture, the major axis is vertical, and this distance then is A. And because A is along the vertical axis, which is the y-axis, then A goes underneath y squared. So it's very important you keep track of which way it goes. But it makes sense because if your major axis is horizontal along the vertical, then it goes along the horizontal axis, then it goes along under the x, which is the horizontal axis. If it's along the vertical, it goes under the y, which is the vertical axis. How do we find the foci? So to find the foci for an ellipse, we use this equation. So let's point out some things here. A, in this first picture, is this distance. It's the distance between the center and the major axis vertex. B is this distance. It's the distance between the center and the minor axis vertex. C is this distance. It's the distance between the center and the foci. So both distances will be equal, but one would be, if it's centered at the origin, one will be negative on the x-axis and the other one would be positive. And we use this c squared equals a squared minus b squared to find c. Example 1 says graph and locate the foci of this equation. Now, if you'll notice, first off, this equation is not in the form that we need. We need it to be in the form of x squared over either a or b squared, we'll wait on that, plus y squared over either a or b squared equals 1. Okay? So what we've got to do is take this 16x squared plus 9y squared equals 144. And our focus here is to get the 144 to be 1. So what we do is we just divide everything by 144. When we do that, we'll get 1 at the end. And here, on the top, we'll get 16 divided by 144 is 1/9. So it'll be x squared over 9. 9 divided by 144 is 1/16. So it'll be y squared divided by 16. Now we're in the correct form. So the center of this one is at 0, 0, because we don't have anything added or subtracted to the x and y. Then the next step is to find A. A will be your bigger number, okay? So in this case, A is 16, or A squared is 16. So I can go back up here and say that A was under the Y and B was under the X if I wanted to. So A is your bigger number. That also tells us that the major axis is vertical because it's under the Y. The bigger is under the Y. We can find A then by taking the square root of 16. That'd be positive or negative 4. That means that the vertices along the major axis will be negative 4, 0, and 4, 0. So let's go ahead and go over to our graph and start graphing this. We've got a center at 0, 0. We've got our major vertices at negative 4 and 4 along the x-axis. Or, nope, it's along the y, isn't it? Okay, so we need to change that. Okay, next step is to find B. So B squared is this number. B squared is 9. That means B will be positive or negative 3. And I wrote these vertices wrong over here too. I'm sorry. It's 0, negative 4, and 0, 4 because they're along the y-axis. Okay, since B is positive or negative 3, then that means the other two vertices will be at negative 3, 0, and 3, 0. Now we're pretty much able to draw our ellipse. Be careful with this. It doesn't have to be perfect by any means, but don't do this still. That is not an ellipse. So that's not acceptable when you graph these. And mine's not perfect either, but at least it's curved and resembles an ellipse. Now the other thing the question asked for was to find the foci. So we're going to do that too. To find the foci, we use our formula c squared equals a squared minus b squared. So c will be the square root of a squared was 16 and b squared was 9. So that's the square root of 7, which we'll go ahead and change to a decimal because we're going to graph this. So approximately, this is plus or minus 2.65. Therefore, our foci will be at 0, negative 2.65, and 0, 2.65. And we'll graph these. Just get it as close as you can. It doesn't have to be perfect. But there are our foci, and when you graph these on your lab, you are required to graph the foci and all the vertices and the center, just so you know. So that concludes example 1. For example 2, it says, find the standard form of the equation of an ellipse with foci at negative 2, 0, and 2, 0, and vertices at negative 3, 0, and 3, 0. Now, I always find it helpful when I've got a problem like this to start with graphing it. So it says that the vertices are negative 3, 0, and 3, 0, and that the foci are at negative 2, 0, and 2, 0. Okay, so what does this tell me? Since the foci lie on the same axis as the vertices that we were given, then that means that our major axis is horizontal. That means we're going to, since the center is at 0, at the origin, then that means that our equation is going to look like x squared. I'm going to go ahead and write this like that. And since the major axis is horizontal, a squared will be under the x, and b squared will be under the y. How do we find a, b, and well, we've already got c. How do we find a and b? Look back at your picture. A is this distance, 3. So since a is 3, then that means a squared must be 9. To find b, that's going to be a little bit more difficult. We know that c is 2. So we can find b using one of our formulas. I'm just going to use the same one as before, just to maintain consistency. So c squared is a squared minus b squared. We've got c. Remember, it's 2. So 2 squared is a squared, which was 9, minus b squared. So b will be the square root, plus or minus, the square root of 9 minus 4, or the square root of 5. So if b is the square root of 5, then what's b squared? Well, the square root of 5 squared is 5. So on the bottom here, we put 5. Now, in order to graph our ellipse, then we need to know what b is as a decimal. So that is approximately 2.24. So b is going to, our other vertices will be at 0, negative 2.24, and 0, 2.24. Something like that. And now we can graph our ellipse. And there we go. And remember, our equation is this right here. X squared over 9 plus y squared over 5 equals 1. Okay, now what happens when the ellipse is not centered at the origin? Well, in that case, your equation looks like this. It's still the same fact where A is under the major axis, okay? But you've got x minus h and y minus k, where h and k are the center. At that point, things change a little bit as far as finding the foci and the vertices. If the major axis is horizontal, then, and the center is at HK, then if this distance is A, then this vertex will be at, like it says here, nope, up top, H plus A, and then K, because it's the same y value as the center. For the other vertex, it would have the same x value, and then we would have K, I need to go up top so we can say plus. So up here, it would have the same x value, but K plus B to get to that vertex. Then for the foci, if this distance is C, then you would say H plus C and then K, because the y value is the same. The formulas for finding C are the same. Along the vertical axis, if the major axis is vertical, the center is still at HK. A squared is now under the Y, just like when it was centered at the origin. But finding the vertices and the foci are different. So if this distance is A, then your vertex would be H, because it has the same x coordinate, and then K plus A. So this number plus A, and A's going up to there, would give you your y value. Then to find the other vertex, this distance would be B. So we'd have H plus B and then K, because the y value would be the same. And then for C, the x value is the same, but you add C to K to get the foci. So some students like to look at these formulas and go by the formulas to find everything. I like to graph and then work backwards. I find that easier, and you'll see what I mean. That's the way I'm going to go about solving these. So, example 3 says to graph this equation. The first thing we want to do is pick out the center. The center is HK. So H, let's write down our in general equation here. So we'd have x minus h squared and y minus k squared equals 1. And in this case, we can already see that the B, or the A, is the bigger value. The A is under the x. So we'll put a squared there and b squared there. So the center would be the opposite of this number. So not 1, but negative 1. And then not negative 2, but 2. So the center is at negative 1, 2. I'm going to go ahead and graph that. Okay? Since the bigger number is under the x, that tells us that the major axis is horizontal. So those where our major vertices will lie and where our foci will lie. So the first step then is to find A. A squared is 9. So A would be plus or minus the square root of 9, which is 3. That will help us find our vertices. So what I do is I go over to the graph, and from the center, horizontally, I'm going to count 3 to the right and 3 to the left. Now I don't have to worry about those formulas, remembering what's h minus whatever and all that stuff. I can just look at my points. So one point is at 2, 2. And the other point is at negative 4, 2. So those are two of the vertices. The other 2 vertices are found by finding B. B squared is 4, so B is positive or negative 2. And we'll come over here and go 2 down from the center and 2 up from the center. So my other 2 vertices are at negative 1, 0 and negative 1, 4. So now we've got the center and the 2 vertices. All we need are the foci. To find the foci, we use c squared equals a squared minus b squared. So in this case, a squared was 9, b squared was 4. So it'll be plus or minus the square root of 9 minus 4, which is the square root of 5, or approximately 2.24. So I'm going to go over to my graph again. I know the foci have to lie along the major axis. So to the right of my center, I'm going to go 2.24, and to the left, 2.24. So then what's this point? It would be 1.24, and then 2. So go write that down. And then the other vertex would be or the other foci, excuse me, would be at 3.242, or negative 3.24, excuse me, 2. And now we can draw our ellipse. Example 4 asks us to find an equation for the ellipse with center at negative 1, 2, one focus at negative 3, 2, and the vertex at negative 5, 2. So I'm going to start by graphing these points that we've been given so far. So it says the center is at negative 1, 2. There is a focus at negative 3, 2, and a vertex at negative 5, 2. Now I'm going to use these points to help us find the others. So if the vertex is 4 to the left of the center, then we have another vertex that will be 4 to the right of the center. Right there. And then if we have a foci that is 2 to the left of the center, then we have another that'll be 2 to the right. So this helps us find A and C. So A, the distance from the center to one of the foci, is 4. And C, or excuse me, that was the distance from the center to one of the vertices. And C, the distance from the center to one of the foci, is 2. Now, how do I know that this distance is A instead of B? Well, I know that because the foci are going to lie on the major axis. So that means that these vertices that we've got plotted here are also on the major axis. And the major axis uses A. So that I know that I'm using the formula x minus h squared, with the x coming first because the major axis is horizontal. Let's write that down. So x minus h squared over a squared plus y minus k squared over b squared equals 1. And so we've got A. That will be 4. So A squared is 16. And we've got C, so that can help us find B. I'm looking for another color. Okay, so B squared will be A squared minus C squared. So that's 16 minus, we were told that C was 2 from our graph, so C squared is 4. And so B squared is 12. If B squared is 12, that tells us that B is the square root of 12, or approximately 3.46. So we can now go graph those two vertices. there'll be 3.46 up and down from the center. So 1, 2, 3, almost halfway. 1, 2, 3, down and almost halfway. And so here is our picture. The only other thing that we were missing that I need to add in is our center. So we know H and K, but that was given to us. So the center was at -1, 2. So X minus -1 and Y minus 2. And we will rewrite that. So we don't want to leave it as X minus -1. So it'll be X plus 1 squared over 16 plus Y minus 2 squared over 12 equals 1. So there's our equation, and we've already graphed it because we used the graph to help us write the equation. For example 5, we're going to write the equation of this ellipse in standard form and then identify the center, foci, and vertices. I'm just curious if I have a graph. I do. Nice. Okay. So, how do we write this in standard form? You can't go do like we did on the first example and just divide through. That won't work, because we're not centered at 0. So what we have to do is group our x's. 9x squared plus 18x. And then group our y's. Plus 5y squared minus 30y. And I'm going to go ahead and get the 9 over to the other side just by subtracting it from both sides, -9. Next step is to factor anything we can out of our pairs. So we're looking at a pair here and a pair here. We can factor 9x. Well, we're not going to factor the x out, just the 9 out of this pair. And we'd be left with x squared plus 2x. Out of the y pair, we can factor out a 5. And we still got our -9 sitting over on the other side. Okay, so the next step is this. We have to, guess what? Complete the square. So all I'm doing is rewriting what I had in the previous step with some blanks. So we're going to add a blank here. We're going to add a blank here. On the other side, if we add something to the left, guess what? We got to add it to the right. So we're going to add that same blue blank and the red blank to the right. How do I know what to add? Well, remember completing the square. If you've forgotten how to complete the square, I think I've provided a video somewhere in here in a previous section, one of our first sections, or you can look it up on Khan Academy. You've got, for this first one, you take b over 2 squared. So b here is 2. So we've got 2 over 2 squared, or 1 squared, which is 1. So in the blue blanks goes 1. For the red blanks, our b is -6. So negative 6 over 2 squared. That's negative 3 squared, which is 9. So in our red blanks goes 9. I've got to pick this up, take it to the next page. Okay. So now factor. So the whole point of completing the square is so we can write it in the form x plus something or x minus something squared. If you look back, this number in here, just this b over 2, is what goes here. But it's also the square root of this number. So the square root of 1 is 1. That's what goes in that blank. Then we've got 5y. This time it's minus because of the negative in front of the 6y. And the square root of 9 is 3. Over on the right, we need to simplify. And crap. I didn't do something. Okay, so over here, we've got, right here, we've got 9 plus 1 plus 9. That's not quite right. This 1 was multiplied by 9 because we factored out a 9. So we have to put that 9 there. This 9, we had pulled out a 5. So we have to multiply that 9 by 5. So what we've got over here is actually negative 9 plus 9 plus 45. I'm sorry I didn't catch that the first time. But now you see we just took this 9 and we have to multiply the 1 by 9 on the right because technically you're adding 9 to the left, and then this 9 has to be multiplied by this 5. Okay, so negative 9 plus 45 is 45. One more step here. The last step is to get this to be 1. And in order to do that, we need to divide through then by 45. And if this is an ellipse, then things will turn out pretty nice. 9 divided by 45 is 1/5. So we have x plus 1 squared over 5. 5 divided by 45 is 1/9. So this is y minus 3 squared over 9 equals 1. So we have our equation. Once we have our equation, we can find everything we need to find. So I'm going to bring this over here. The center isn't difficult. It's at negative 1, 3. The vertices. The major axis, in this case, can you pick it out? Because the bigger number is under the y, the major axis is vertical. So that means a squared is 9. So a is plus or minus 3. So where are the vertices? Like I said, I like to graph these things and work backwards. So our center was at negative 1, 3. Since the vertex is 3 and negative 3, then we're going, and the major axis is vertical, then we're going up 3 and down 3. So our two of our vertices are at negative 1, 0 and negative 1, 6. Then b squared is 5. So b is the square root of 5, which is approximately 2.24. Oh, wrong direction. Okay, so to the left, I'm going to go 2.24. To the right, I'm going to go 2.24. So that means that the other two, oh, I went over. There we go. The other two vertices are at 1.243 and negative 3.243. And last, it did ask us to find the foci also. So I need to move things around a bit here. We find the foci, c squared equals a squared minus b squared. So c will be the square root of 9 minus 5. That's the square root of 4, which is 2. So again, I'm going to go back to my graph. The foci have to be along the major axis, which was vertical. So 2 up and 2 down. So the foci are at negative 1, 1. And negative 1, 5. So we now have our equation, the center, the vertices, and the foci. And just for the fun of it, we'll come back and graph the ellipse real quick. Okay, our last example is an application, a very important application. Will this truck fit under this bridge? That's very important, right? Because, you know, if it doesn't fit, it's going to scrape or knock its top off or get stuck or even knock down the bridge. Bad stuff. So we've got to figure this out. Very important for this truck driver. Says a semi-elliptical archway. Semi-elliptical just means it's half an ellipse. Obviously, it's not going to go all the way around. Semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Have you ever been under a bridge on a one-way road? I can only remember one in my mind right now. It's in Lexington, North Carolina. And it's a little bit scary because you never know if something's coming the other direction. But anyway, so it says that the road has a height, or the bottom of the bridge has a height of 10 feet and a width of 40 feet. It says, will a truck that is 12 feet wide and has a height of 9 feet clear the opening? Well, you'd like to say, well, the height's 10 and the truck is only 9 feet tall, so of course it's going to go through. But no, no, no. Because it goes down. It's only 10 at the very center. So is 9 going to hit the edges here? That's what we've got to find out. So to make this easy, we're going to make our equation center be at 0, 0. Okay, there's no point in making it at negative 2, 5 when we don't have to. Make it at 0, 0, make it easy. So, where are the vertices then? Let's see, do I have a graph? No, I don't have one to draw on. That's okay. So, if the center is right here on our picture, then our major axis is the horizontal, and A will be this distance. And what's that distance? Well, it's half of 40. Or 20. So, let's start with our equation. Since we're putting it at the center at 0, 0, we don't have to worry about H and K. We've already verified that our major axis is horizontal. I like to write this down so I don't forget it. So since our major axis is horizontal, then A squared is going to go down here. We just found A, it's 20. So A squared will be 20 squared, whatever that is. Which we could go ahead and find that out. It's 400. What's B? B is this distance right here. From the center up to the top of, or the bottom side of the bridge. So it's 10. So on the bottom under y squared will be 10 squared, which is 100. So we have our equation. We can graph the vertices and everything, but we don't need to. We've got the equation. We're good so far. What we need to do now is we need to find out if this 9-foot tall truck is going to fit. Now the truck is 12 feet wide. And we're just assuming it's going to go through right in the middle. So that means that if it's going through right in the middle, then it's going to go 6 feet to the right and 6 feet to the left. So what we need to do is we need to plug in where X is 6 feet. Solve for Y, see if it's going to fit, okay? Okay, so let's do that. So 6 squared over 400 plus Y squared over 100 equals 1. How am I going to solve this? Easiest thing to do is to start by multiplying everything by 400. So 6 squared is 36, and we've got nothing left on the bottom. If we multiply y squared over 100 by 400, 400 divided by 100 is 4. So that's 4y squared. And 11, where did I get 11 from? That's a 1. 1 times 400 is 400. Solve for y. So we got 4y squared equals 364. Y squared is 91. So y is the square root of 91, or we'll go with 9.54. So, what is the height? The height of the archway, let's write this out. The height of the archway at the width of the truck is 9.54 feet. So will the 9-foot truck fit? Yes. Looking at a picture of this, you can see where we've got the center here at the origin. We've got the vertices at -20 and 20, the height at 10, and this truck is going out 6 that way and 6 that way because it was 12 feet wide and 9 feet height. So it will barely make it. It better go directly in the middle of that bridge. And that finally concludes our section on ellipses.